Hi, my name's Gary Taylor, and in this we're going to look at Mediator Part 2. Mainly because I made such a mess of Mediator Part 1, I felt it was only justified that I try and recorrect some of what I was saying in Mediator Part 1. Um, if we head back over to the Mediator page, and please make sure you've watched Part 1, otherwise a lot of this won't make any sense. So the Mediator Pattern is a way of allowing us to decouple the thing that asks for things and the things that do the things, which is really what a service bus is all about. So if you're using RabbitMQ, you're used to this. You shout out to the ether, "Hi, can someone please send an email?" And some consumer somewhere is subscribed to that message and does it. If you're, using the browser, you might echo out an event to the DOM, and something somewhere will be hooked up and listening to that. There'll be some kind of publisher subscriber. So this idea of mediation and allowing somebody else to do the work for us is kind of the bread and butter of everything that we're talking about when we're dealing with mass transit and any kind of queuing system. And that's probably where I've got a little bit confused with this, is that it's just more of the same. It's a mediator pattern, but it allows us to actually do this without the need for a service architecture. In other words, we don't need RabbitMQ or some other transport layer service to actually deal with this. This is just all done in memory and is really quick. It's by reference. And I've gone through these examples. And in the previous video, I set this up where we created a mediator and we submitted off an order. So let's say we want to buy some ice cream. We put an order ID in, and then we want to be able to get the status of that order back. So at this point, we get the response back. And the rest of this code has the order status consumer. So this replies back with an order status. And then this just shows how to use a service collection to do it. So it's the same thing. So at this point, we start looking at submitting order consumer and order status consumer, but the code isn't here. So if I do a find for submit order consumer, that's a caller, that's a caller, well, that's just registering it. So the submit order consumer doesn't actually exist on this page. There is no documentation to it. So I just made one up, and I didn't really do a very good job of it, to be honest with you. So that's where there was a bit of confusion. So just to walk you through the code, we've got the same thing as what you just saw on the screen. We've got two consumers, which is submit order and order status consumer. And then we send an event out, and note that we don't care who picks it up. We're just shouting out into the ether, "Hi, here's an order, somebody somewhere deal with it." And then later on, we can actually get the response of that order. Well, this is really unusual code because it's asynchronous. We're going to get an AO8, then we're going to get the response to that, but we actually haven't said who is responsible for dealing with that order. Nor have we actually said who's responsible for giving us the status of that order. We have just got two lines of code really, which is to send the order and get an order. But there's a lot going on under the hood here. And this is why I think I didn't do a good job in the first one, because I didn't quite see exactly how much was happening within these two lines of code. So to give it a bit of a breakdown, I've just put a couple of printouts in there. One is to get order ID and just to print it out. And this is, generic really. A customer comes along and he orders an ice cream, so he's going to get an ID for that particular order. And he might want to buy 2 chocolate ice creams, and we push that out. And we say, right, let's submit this order. And something somewhere will be listening to that. And it just so happens that we've registered a couple of consumers. Now you can register these consumers when we first fire up the app, or you can actually just connect consumers at runtime based off different logic. So that's a really nice feature. So if we look at the submit order, the submit order should be responsible for dealing with this interface. And it is. It deals with submitting orders. Now at this point, I've made this up because it wasn't in the documentation on that page. So I kind of just copied and pasted what we had here in the one that is in the page, which is the orders status. So this one didn't really exist in the documentation on that page. So I've just copied and pasted this, made it up, and I've got the exact same thing which sends this, which is technically wrong because you wouldn't do this because the order status has got nothing to do with this submit order. You'd probably want to publish a message to say that order submitted order complete or something like that, a finalized message to say it's been done. Because the code that you would have that processed an order would be in here. So connect to the database, add the order to the database, remove the person's credit so that you took the order and you took the amount of money off the credit card or whatever. All of that logic would be in here. And once that's done, we have the ability to call the order status consumer. So here we have the ability to go and get the response back. So we can say, go and get an order status. And the status that I'm interested in is for this order. Now we know it's already been done because we AOAted it. So we're done here. That's cool. And we can now actually go and get the response and the status of the order. So if we give that a run, we get this really nice, here's our order. Come along, we've got the order. The producer is going to handle this. And when we've submitted rather, so we're going to send this off here. So when we publish that message, anyone that's interested in submit order would be listening. So we've got this consumer now firing here. And then what we want to do is we want to get the response. And there's a consumer that's responsible for dishing out order statuses. So this one fires here, and the order we get is completed. So down at the bottom, I changed it a little bit now so that that gets pending. Remember, this is wrong. I'll fix this in another video, but or even maybe this one. This is wrong. We don't need this here. The code that would be here would be the actual thing that processed the order. And the code here would actually get this order ID, check against the database to see if it's completed or what status it's currently at, and it would then return that the status. So the code for checking an order would be here, which means that we've got really decoupled code. Anybody who wants to check an order can just raise an event and get this response back. And anybody who wants to submit an order can raise a response and this will happen. And at any time we can hop swap them. You know, if we get a deal of the day, a Monday deal of the day, we might have a 10% discount. Well, instead of messing with the code that we've got that we know works, we can extend it. We can get submit order Monday, make it extend submit order consumer, and then put the logic in there to give us a 10% discount. Then on Monday, we would just simply register that consumer instead. And on Mondays, we'd have 10% discount. And on the rest of the weeks, it would just flip to use the normal consumer that it's been using forever, that we know doesn't have any bugs, that we know has been running in production for months and is fine. So it's a really nice way of being able to decouple real logic. And I want to give you an example of that in that if we're not interested in getting the response back, we're not interested in the status of that order. Let's comment that code out. In fact, I'll need to comment it all the way down to here. So let's take that out. We'll now see that we will call out to send an event, send a message out. Our commented out too much, having like an idiot. Here we go. So that did nothing, obviously, because there's no code. But here we'll send an order out, and something somewhere will process that order for us. So here we go. We sent it out, and the submit order consumer processed it. Now, we don't know how. We just asked somebody to do it. And because we didn't ask for the status order, we didn't get that back either, because we didn't ask for it. So now we do. We'll shout out into the ether, can somebody please manage this order for me? And then we'll say, right, that order that's been processed, because we know it's been processed because we awaited it, can I get the response back, please? And somebody comes back with a response. Completely and utterly decoupled. Now, the mistake that I had in my head was that I believe these things were tightly coupled together, which kind of defeats the whole purpose of a mediator pattern. I thought that what we were doing here was sending a particular order, like order ID 7, and then this would get the response back for order ID 7. That's completely arbitrary. If I had a different order ID in there, I would get a different response back. They're not tied together. That and that are completely two separate requests for information. The fact that we're actually asking about the same order is irrelevant. It's just the way the code works, the way we've currently written it. But I could quite easily ask for a different order response here. And it just so happens that your code probably wouldn't do that. You know, you're going to process an order and ask for the response of that order. But these things are completely separate. They're not related. All we need to worry about is that deals with submitting an order, and that deals with getting an order back. So if I copied and pasted this code 20 times and put in 20 different order IDs, obviously within the get order status consumer, it would read that order ID, check the database, and return back an appropriate order. Order status. So in my previous video, you'll have heard me worry about this. So I'm creating an object here that's being passed into get response. Well, I response object, which is basically going out to this mediator pattern and getting the response, basically calling it out, and some consumer somewhere will be listening to it and will process it. And it's going to get back an order status. Now, in order for that to work, the mediator needs to know what the hell it's asking for and you know, give the consumer a fighting chance. So here we have this client, and this client is creating a request to anything which is the get order status, which means it's going to be inadvertently subscribed to the order status consumer, because that's the thing that deals with get order status. This is where it starts to pickle your brain. And what we're doing here is we're creating an anonymous type, but it's going to be cast to that type, I believe. So get order status. If we have a look at get order status, we just have an order ID. And we can decorate that with more data if we want to. That means when this gets called, the value that comes in will be this get order status object. And you can see there, you know, we've got order ID, we've got IntelliSense and everything because it knows what it is. And then it returns back an order status. So with that, we then get a request with get order status and a response of order status. The order that we're interested in is this order ID, and now we've got a response to this order ID. Wow. You know, we're talking, 15, 20 lines of code, take away all the comments and crap and boilerplate. In fact, you're probably talking 3 or 4 lines of code with just the send, get response, and maybe a couple of printouts. And there is so much going on here. So because I still really didn't get it, I'd created this little diagram which allows us to visually see per pseudo how this thing is working. And we've got something that sends and that submits an order. And we don't know how because we don't really care because it's not our responsibility, but something somewhere will consume that message and we'll get a response. Now, if we try and read the response back, it'll then go to this consumer, which is the order status consumer, and send the response back. So we can send out into the ether, can somebody process this order? And this thing will do it. And then we can read the response from that order, and this consumer will be responsible for reading the response. Now, if we don't really care about that, we can just simply get rid of all of this, and we can just submit an order and get a consumer to process it. So that's the magic that's happening with this mediator pattern. Now, there is also more going on with these objects. Bear in mind that we are not creating an instance of a concrete type. These are just anonymous objects. And because of that, they can be cast to the types. And it also means we don't actually need to make a class of order status. And a very common pattern actually is to not even put an I in front of it because it kind of makes you feel like you have to make an instance of it when you put I in front. And it's not that MassTransit doesn't like the I convention because it uses it. It's just that here it's not needed because we don't want to even allow get people to think in that way. It is just these are the templates, the contract that you're going to abide by. And it also means that there is clever stuff that we can do with this. And there is information that's used to serialize this data. Now, we can pass in loads of information to an order status. So I'm going to give this a bit of a play. I shouldn't really do this whilst coding, whilst on the video. So what I'm going to do is I'm just going to try and extend one of these. So submit order. Let's put an int in amount. So we've got submit order. So just give that a run just to make sure that I've not broken anything. So when we send, we're going to send out a message, and the thing that we're going to send is a submit order. And this is really cool because you use interfaces as doers, as things. So submit order is this consumer now. So if I have a look at this, total message dot amount. Let's make that amount. If we run that, so we can see we're processing that order request. We're submitting, gone to that consumer, and the consumer can see that order ID, we want 10 of them. Well, 10 what? well, it doesn't matter. We've not put it in yet, but of course we could do. We could put a product ID in. We could put an actual amount of the order. So whatever information you need to be able to process an order, a payment, or someone buying something from your shop, you just put the values in here, and that gets passed in. Whatever that consumer needs to be able to process an order, you just pass them across as variables. And you're just seeing how easy it is for me to change that. And it's same for the stuff coming back, obviously. Obvious to me now. Uh, when we get a response, we're going to get this order status back. Well, we could have maybe an ETA, or something that lets us know how long it's going to be until our order is completed. How many people are in the queue ahead of you, type of thing. You can go and find that out, populate that, and return it back. So that's pretty cool. We can now pass data around, but we're only dealing with data, not the how. As a programmer, I'm going to be able to send out a request and get a response back, and I do not care how that's happening, who's doing it, what code's running it. Could actually be, once you hook it up into like a proper service bus into RabbitMQ, it could be some Java or Python or some C++ code that's actually processing this and returns the data back to you. It's awesome, really, really cool. There is also more to this as I've started going along. So I want to just raise a shout out to Fat Boy G, who helped point me into the right location. He showed me where message initialization comes from, because I just didn't quite understand this structure at all. Didn't make any sense to me when I first went over it. Now I get it. So he redirected me to this part of the documentation. And here is where we talk about using anonymous types, and we use them as contracts to be able to pass data around without them being concrete objects. And MassTransit deals with serializing and deserializing the data and passing them into object types. So this actually is kind of the missing link to the mediator pattern. Here we can see the bloody submit order, and it's like, right. So I would have got there eventually as I work my way through this documentation, but the stuff for mediator and the missing links to that is actually in here. So it was a bit of a eureka moment once I got pointed in the right direction, which was great. But one of the lovely things that we talk about is not only the ability to pass that data back, but also to sneak in extra information, to sneak in extra data into your objects that aren't actually within the interface, which is really, really odd, but very, very cool. Because sometimes your contract needs to be extended. You need to be able to add data in. Now, if you've got a contract library and a huge team, you might have 30 or 40 teams all working, and a contract change needs negotiation. But you've got a deadline, you're in your sprint, you've agreed to do this work in the next 2 weeks, but it's going to take longer than that for your teams to agree on a contract change. You can actually sneak in some data into your objects. Not really the way, not really the point of this, but it can be used for that. The real bit and a value is things like tracing, like zip keying or something like that, Datadog, APM tracing, where you can actually monitor and trace calls as it passes across different architecture and different distributed systems. So if we take a look at this, there's this syntax where if you put underscore header and then underscores, then it gets converted and gets put into a header attribute within your message. Now it's easy to see than talk, because it took me a while to figure it out. So let's submit this order. And I'm just going to drop this down to make the code a little bit easier to see. Okay. And what I'm going to do is I'm just going to put that in, but I'm going to just put Zipkin ID, you guess. Zipkin trace ID, you guess it. I just could have put everything Bob, but any kind of data that you want to submit across that isn't in that interface can actually be put in using this notation. Now, what I can't remember off the top of my head is actually how to read it. So I'm just going to do some debugging. So I've got submit order. The thing that's going to process this is a submit order consumer. So if I put a breaky point here, F5 this to run, hopefully it's still set up and I can debug straight in and have a look at my context. So we've got context and I believe that it should have headers. Yep, headers. Yep, go and get my results. Don't care how. So we've got a key now called XB3 trace ID, and you can see the message that I passed in, the Zipkin trace ID. You guess it, or guessed it. So I can now read that key within my consumer without changing my contract. And let's take that and show you that. So let's do it. I think it's got a getter. So headers, getters, headers, get, and then you want the header and the default value if it doesn't exist. Bob. So let's run this. Just run it on the command line. I don't want to run it by F5. So it's Bob. What did I mess up? Did it have an X in front? Might have done. There we go. Yeah, it had the X in front. So we can see now B3 trace ID. And really, I should put an X there. Has been passed in, and we've got that value of Zipkin trace ID. You guessed it, and that allows us to pass in extra parameters. Now, I'm not quite sure what happens if we put in parameters that don't exist. So let's put that into here. Does not exist equals true. Let's run this. I think we get a serialization error. No, run. But I don't think there would be any way of actually reading it. Submit order. What processes submit order? This does. So let's F5 that. So if we've got message, we've got the amount and the order, but obviously the does not exist property isn't there because it didn't exist. Not quite sure if there's anything else, any other non-public things that are there, but no, that's it. Whether it gets hoisted, I'm not sure. Whether any missing things get passed up into the top, I would doubt it. Is it available in green pipes? Is the no? So I was surprised over that. I did expect actually to get a serialization error as the producer was giving us data the consumer isn't visibly seeing. So that was surprising. I did expect some kind of bug, and I'm sure I've seen a serialization error in the past as I've been playing about. So I'll dive into that and see if I can work that out. Now I hope this gives us a better understanding. It certainly has helped me. So thanks again to Fatboy G. It's just for pointing me in the right direction. It shows that the mediator pattern is incredibly powerful. It allows you to decouple a lot of logic from the system. My current concern with the little bit of knowledge that I've got at the moment is that by doing this, it's really tricky to see what is and isn't being done and who's doing it. Uh, One of the things with Java is the dependency injection that's done at runtime. You know, you configure it with XML files or whatever, and um, uh, even YAML files as well. Now, you know, you can configure how all the dependencies are pushed in and managed. That when you're in code, you have no idea what's actually happening or who's doing what. And like I say, it's kind of good from a developer's point of view. You know, you just send out an order, you don't care who processes it. But when you're then responsible for having to debug it and to figure out why it's not working, well, sometimes just working out who is actually in charge of submitting orders, when you have a look at it and there is like 30 consumers all for submitting order, and then some conditional logic that's adding them. And then when you have the ability to connect, where is it? Connect requests, connect different consumers, sometimes with an if statement, a switch statement, or whatever around it, it then becomes really tricky to debug that problem of, for some reason on a Monday morning, there's 10% off everything. And, you know, that happens in businesses. Business makes very fast decisions, and work is being pushed out and business logic is being updated. These things can sit around, floating around in your system, and they become legacy code that no one quite knows where it is. And you need to be careful when implementing this type of pattern that you have got a centralized unit of work that deals with setting up consumers, deals with setting up the mediator, deals with any kind of Monday 10% discount logic, and is backed up by unit tests. You know, if there is a Monday morning discount, then you should have a Monday morning discount unit test that pretends and mocks out that it's Monday today and checks that 10% has been taken off the items that have been agreed. And then on Tuesdays, then Thursdays and Fridays, it isn't. And tie that to like some Jira ticket or, you know, DevOps ticket or whatever you're using, just so that as a business, you know that when that was agreed by the business, when the code was put in and where the code is. And that's a good way of being able to make sure that you can keep track of all this. I was getting confused with just this, and this isn't right, not fully. I'm still getting there. And I was getting confused by what it did. And there's only three things. So with a system that grows and grows, you might have 30 consumers that all are interested in an order being completed because they all need to do different things with different parts of the system. And that can get tricky, but it can also be fun and powerful if done in the right way. Now, code is like that. I'm going to finish on this because I don't want to go into a big rant all code can be good and all code can be crap. So it all depends on the quality that your team put into making it good. And when you don't know enough about it, you will make bad choices. So it's important that we all get a grasp of the technology that we're using and we make sure that we understand it fully or as well as we can before we start building major systems with it, because it's difficult to change after we've made a mess. And you know the least when you first start. So this is the mediator pattern. It allows us to nicely delegate responsibility. It allows us to get started with mass transit type consumers and producers. It also allows them to be refactored out and moved to a service bus type architecture once one of these things starts to get um, the bottleneck or becomes a problem, or even when it's 90% of the developer's code touch is all in like a handful of producers, then it's time to move them things out, separate them, allow it to be easier for the development team to work on. And this is a great way to do it. So I actually like this mediator now I know more about it. So thanks for watching. As always, if it's been useful, don't forget to subscribe. Cheers.